So in this short video, I'm going to go over a couple of examples from section 1.2 of our textbook. Section 1.2 is about problem solving with patterns, and the examples I'm going to go through in this video are from the first section of part of that on terms of a sequence. Now, the author of our textbook has made a video introducing the topic, and I urge you to watch that video. It's a good one, and it sets up the situation that we're dealing with. And then after the video, the section goes through this example where you're trying to predict the next number in a sequence. And actually it has two examples, and the first one here is pretty easy, and then the second one is kind of challenging. And the reason why I'm making this video is I think the second one needs a little bit more explanation so you can see how they arrive at the solution. And so I'm just going to move the camera over here to a piece of paper where I can write. Well, I'm getting there. Let's see. There we go. Okay. So we're going to make what's called a difference table for the sequence. We subtract. 5 minus 2 is 3. And we see that the differences are just 3 every time. So we predict the next number is going to be 17. And that much is super easy. We want to make a formula for the nth term. Now, what do I mean by that? The first term, A1, is 2. And A2 is 5. And A3, the third term, is 8. So it goes. So we want to make a formula with an n in it to tell us what's the number at the nth term. Okay. Well, from the pattern we see you're just adding 3 every time. So the nth number is just a bunch of 3's plus some starting place. So I'm going to say 3 times n plus something. See, 2, it's 3 times 1. If n is 1, we're looking at A1, so n is 1. If n is 1, then we get 3 times 1 plus -1. Let's see if it still works. If n is 2, we get 3 times 2, that's 6, plus the -1 is 5. And then when you get to 8, if n is 3, 3 times n, that's 3 times 3, is 9, plus the -1 is 8. So it's matching, and so we say, okay, an is 3n minus 1. Okay, and then we can predict the sixth, the next number if we want to. We predict A6 equals 3 times 6 minus 1, or 17. When it's only a conjecture that it's going to go on like this. As I mentioned before, you can always make more than one pattern that would fit a list of numbers. And so here we've just picked up on the simplest possible pattern, And if that really continues, okay, then the next number is 17. But we can't be sure. And so that's the limitation that we have with inductive reasoning. Now, the next example over here in the textbook is a little bit harder because the differences don't stay the same every time. And before I even address this problem, I want to do a little side note and get a formula that we can use later in this problem. So if you want to add up some numbers, let's say we want to do 1 plus 2 plus 3 plus 4. We'll just add up the first 6 natural numbers. There's a little trick you can do. See, 3 plus 4 is 7, and 2 plus 5 is 7, and 1 plus 6 is 7. So what we got was 3 7s, 3 times 7. Now what if we wanted to do that in general? What if we wanted to go up to 20? Well, we do them in pairs again. We're going to have 21. It's the 1 plus 20. And then we're going to have 2 plus 19. That's still 21. And then 3 plus 18. That's still 21. So it's 21, 21, 21. We got 20 numbers there. How many pairs are there? There's 10. So we're going to have 10 21s, or 210. Okay, so what if we want to do 1 plus 2, and then we just want to stop sometime. We want to stop at n. Well, you put them in pairs. You have n plus 1, and then you go down 1, n minus 1 plus 2, so it's still n plus 1. So it's a whole bunch of n plus 1s. How many n plus 1s are there? Well, like if n was 6, there were 3 of them. And if n was 20, there was 10 of them. And it's n over 2. You may be a little worried, well, what if it's an odd number? It still works out. I'll just do that briefly over here to the side. But what if I wanted to do 1 plus 2 plus 3? Okay. Well, I get 6, right? And what is that? That's 3 plus 1, it's n plus 1, times n over 2. See what I mean? 3 over 2 times 4, it's 6. So it still works with the odd numbers as well. So this is a formula for the sum of the numbers from 1 to n. You get n over 2 times n plus 1. Now, Gauss worked that out. Gauss is one of my heroes. He figured that out. Rumor is, I don't know, it's a legend, that he did that when he was in elementary school. I can believe it, you know, because it's not that hard once you see it. Like so many things in math, I'd never think of it necessarily, but once you see it, yeah, it's straightforward. Okay, so we're going to use this formula to solve as a step along the way when we're solving to find the next number in this sequence. So this is now I'm back to the textbook. This is the example from the textbook. You've got 5, 14, 27, 44, and 65. And the differences this time are not staying constant. This time, the difference from 5 to 14, 14 minus 5 is 9, and then 13, and then 17, and then 21. So the differences are not the same every time. Okay, but if you go one more step, we're going to say now they are the same. So these ones are going to, 9 plus 4 is 13, and 13 plus 4 is 17. So these ones go on. So if I wanted to predict what's the next number, that problem is easy enough. I just predict, okay, it's going to be 4, and then on the third row, and then on the second row, okay, that's going to be 25, and then just predicting, then our next number in the sequence, we think that's going to be 65 plus 25 is 90. So we think we've got the pattern. And now, where I think the book falls a little bit short is on telling you the details about, so how do you get the formula for the nth term? Okay. Now, so this top row up here, that's our sequence A. A1, A2, so forth, 3, 4, here's A5. Okay. Well, that one's a little complicated, but the next row is simpler. So this is going to be my sequence B. B1 is 9. B2 is 13. So forth. The 25 here is 1, 2, 3, 4, 5. B5. You know what I want to do? I want to change this a little. I want to call this one, it'll just be a little simpler if I call this one B2, B3, B4, B5, B6, okay? So B1, you know, if I predicted back, going backwards with the thing, the B1 is just increasing by 4 every time, you know. Here's 25, subtract 4, 21, subtract 4, subtract 4. So I subtract 4 again. My next one, my B1, would be 9 minus 4 is 5. Okay. So to get from 5 to the 14, you added 9. To get from whatever's here, you add 5. So that must have been 0. Okay. So 0 plus the 5 makes 5, and 5 plus the 9 makes 14, and 14 plus the 13 makes 27, and so it goes. The point is, we want a formula for this black sequence. It's complicated, but the blue sequence is simple. Let's work the blue one out first. How do you get the blue sequence? How much is Bn? Well, there's some starting point, and then you just add a bunch of 4s. So, what do we start from? Well, like with B1, we started somewhere and we added 1, 4. Okay, so we started from 1. So we're adding n number of 4s. You see, you start from 1 and you add 1 4, you get 5. You add 2 4s, you get 9. You add 3 4s, you get 13. By the time you get to, B4, you would have added 4 4s to that 1 that you started with. So you're just adding a bunch of 4s as you go along to make sequence B. At the nth step, you've added n number of 4s. So there's the formula for the B's. Okay, now that we got the B's, we can work our way up. We can figure out how do you get the A's. So we're starting from 0. So A1, the 5, is just the same as B1. Okay, and A2, what is that? It's the B1 plus the B2. See, A1 was just B1, and then you add B2, you add the 9 to make the 14. So we get our 14. Okay, well, how about A3? Well, that's the 5 plus the 9, 14, plus 13. It's B1 plus B2 plus B3. Okay, so by the time we get up to the nth term, we've come to B1 plus B2, yada, 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 out to Bn, and then we stop. Now, what does all this boil down to? See, B1 was 4 times 1 plus 1. And then B2 is 4 times 2 plus 1. And so it goes. Finally, you get out to the nth one. Bn was 4 times n plus 1. I'm just getting these from up here. For n in general, or n equal 2, or n equal 1, or n equal whatever along the way. Okay. So this is going to simplify down real nice. So what have I got here? I got 1 plus 1 plus 1. Got all those 1's added together. How many 1's are there? 1 here, 1 here, 1 in each term. There's n of them. By the time you get up to n, you've added n number of 1's together. So adding all of those together, this 1 and that 1, so forth, adding all those 1's together gives me an n. Plus
I've got a 4, plus 2 times 4. Next one I got a 3 times 4 and a 4 times 4 all the way up to n times 4. Okay, so I've got 4 times 1 plus 4 times 2 plus yada 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 4 times n. So now an, it's n plus 4 times, using the distributive property, 1 plus 2 plus 3 plus dot 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 up to n. I just see if I distributed the multiplication with the 4 times 1, 4 times 2, 4 times 3, I'd get the inside of that line before. Okay, so we're just almost there now. One more step if you could stand it, and then we're finished. See, what we worked out just a minute ago was 1 plus 2 plus yada 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 out to n. You add up the first n integers, you get half of n times n plus 1. So here's my 4. And then this is just half of n. Well, I can't write, but that's what I mean. N over 2 times n plus 1. Four times n divided by 2. Half of 4 n's is 2 n's. So I have 2n times n plus 1. I'll distribute. I get 2n times n. That's 2n squared. If you're panicking about the algebra because it's been a long time, in this class you're not going to use a whole lot of algebra. Mostly, if the discussion's making sense when you watch, you're mostly okay. There'll be a few problems where you have to do a little of algebra, but it's not a huge part of the course. But you should have had an algebra course in high school. That's the only thing that's really a prerequisite for the course. So anyhow, I have 2n in, that's 2n squared, plus 2n. So we finally come down to our formula. We've got 2n squareds plus 2n plus another n, that's 3n's. 2n squared plus 3n. And so that's a formula for this sequence here. Let's see if our formula is working. We want to predict A6. Now we set up here, we think it's going to be 90. Let's use this formula and make sure we're really getting a 90. Okay. So according to our formula, A6 should be 2 times 6 squared plus 3 times 6. That's 2 times 36 plus 18. That's 72 plus 18. On a good day, that's 90. Yep, it looks like we got the right formula. Okay, so we've just learned three things. We learned how to get the closed form formula for the nth term of a, well, you call this a first order difference table, because by the time you get to the first differences, they're all constant. So that was the first thing we learned. And the second thing we learned was, here's Gauss's formula for what you get when you add up the first n integers. That's the second thing we learned. And then the third thing we learned was how to solve a second order difference table. You just keep doing the differences or the differences of the differences until you get down to a constant, if that ever happens. So this method only works if you find you get down to a constant at some point. But you do those differences, and then you use what we learned about the first order tables to get a formula for the middle row. And then once you got a formula for the middle row, we've got a procedure here. You can go back and review it or kind of write it down, work through it yourself. But to go from, okay, how do you get, now that you've got a formula for the middle row, how do you use that to make a formula for the top row? And finally, your end product is a little algebraic formula for the nth term in the sequence. And that's all for this short video.